Hi, Integrated Math 1. Welcome to lesson 4.1.2b. So we've been determining the better measure of center and spread for a data set. We're on the second day of this. We've already done a bit of this before. We're just kicking it to the next level today, just playing around with it a bit more. So we've already seen that if our data is skewed, whether it's skewed right or skewed left, we've already seen that if it's skewed, we probably should be using the median and the interquartile range. That would definitely be a better measure of central tendency, would be the median, and a better measure of spread then would be the interquartile range. But we also said that if it was symmetrical, we could use either, right? We could use the mean or the median. So today we're going to dig a little bit more into that mean. And we're going to calculate and interpret the standard deviation of a data set. There is a way to actually calculate that. It's just another measure of spread. And we're to determine which measure of spread is best to use for a data set. So of course, our key term today is standard deviation. So we're just digging a little deeper into that measure of spread on our graphs. So the deal is we use interquartile range as a measure of spread if we've decided that the median is the better measure of center. If we decide that the mean is a better measure of center, then we use something called standard deviation to help us find the measure of spread. And to kind of introduce us into this idea, we're on page M4-25. And we have Miss Webb. Miss Webb is determining which student she should add to the spelling bee roster that will represent Tyler High School. And the chart shows the 10 most recent scores for 3 students, for Jack, Aaliyah, and Tamar. So here are their 10 most recent scores. The box and whisker plot displays each of the students' spelling bee scores. Can you take a moment and just describe the shape? Like, is it symmetric, skewed left, skewed right for each student's data set? Go ahead and hit pause, jot down what you notice about the shape, hit play when you're ready to check your work. So I don't know about you, but I noticed that for Jack, Aaliyah, and Tamar, for all 3 of them, their data is pretty symmetric, right? It's not like heavily leaning one way or the other. There's not like an extreme value pulling on one end or the other. So they're all pretty symmetric. I also notice all their medians are sitting right in the middle there, aren't they? So I feel like that's not helping me a lot to decide who we should send on to the spelling bee. Now, we've learned about the spread of data values from the median or the interquartile range, right? But if you know the mean of a data set, right, you calculate out the average, you can calculate the spread using standard deviation. And standard deviation is a measure of how spread out the data are from the mean. Now, I warn you, I'm about to show you the formula for this. Please don't freak out when you see the formula. Please don't freak out when you see the formula, okay? We're going to talk about it. We're going to do all the parts, and we're going to do a whole step-by-step work our way through it, okay? Remember, I'm only mildly evil, not totally evil. That's the formula. The formula to determine the standard deviation of a sample of a population is represented as this. Oh. Yeah, it looks scary. It looks freaky. It's not. It's not. It's several steps, but it's actually not hard. So S is the standard deviation. X sub I represents each individual data value. We already know that X bar is the mean of the data set, and N is the number of items that we're looking at, right? The number of data points. So we're going to look at each part of this separately, okay? So it'll create a little less panic. And let me show you how this works. I'm going to show you how this works. So let's say I have a data set here. 6, 4, 10, and 8. The first thing I need to do is calculate the mean. That is the first thing you have to do. So I'm going to take my 6 plus 4 plus 10 plus 8. And since there's 4 of them, I guess I'll divide by 4. And I'm going to grab my lovely calculator. 6 plus 4 plus 10 plus 8 is 28. If I divide that by 4, I get 7. So the mean, the X bar, is 7. Well, you've already done the worst of it, and it really wasn't that bad. So here's what we're now going to do. We're going to subtract our mean from every single one of these. So we're going to do, see how I have 6, 4, 10, and 8? So I'm going to do 6 minus 7. I'm going to do 4 minus 7. I'm going to do 10 minus 7. I'm going to do 8 minus 7. So all I'm doing is I'm just subtracting the mean from every single one of these. And of course, 6 minus 7 is -1. 4 minus 7 is -3. Don't forget about negatives. We're cool. 10 minus 7 is 3. And 8 minus 7 is 1. The next thing we need to do is to square everybody. Square them, square them, square them. I'm going to take all of these, and I'm just going to square it. Multiply it times itself. Square, 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 square. Don't forget, when you square a negative, it becomes a positive, because a negative times itself, negative times a negative, is a positive. So -1 times -1 is +1. -3 times -3 is +9. 3 times 3 is 9. And 1 times 1 is 1. All right. The final 2 steps. We're almost there. We're almost there. So we found out that it looks like 6 is 1 away, 4 is 3 away, 10 is 3 away, 8 is 1 away. So we're going to square all of them. And then what I'm going to do is I'm going to add them all together. All these deviations that we found all these guys here, these are all deviations. This is how much they deviate from my mean. I'm going to add them all up, and then I'm going to divide. We're used to doing average, where it's you take the number, right? You divide it by that many, so I divided by 4. For deviations, I need to divide by that number -1. That's important. So again, I'm going to grab my calculator. 1 plus 9 plus 9 plus 1 is 20. I'm going to divide 4 minus 1. I'm going to divide that by 3. I'm going to keep it my calculator too. And I get like 6.7 forever and ever. Now there's one last step. The last step is we're going to do the square root. So if we do the square root of this lovely number, which I still have in my calculator, I haven't even taken it out yet. I'm going to hit my square root button. And I get, actually, we're going to abbreviate that. We usually just go to 1 decimal place. So we're approximating it. We're rounding it. And I'm going to say it's about 2.6. Because I got like 2.5819 and stuff. So we're just going to say it's about 2.6. So these are all of the deviations. This, though, is the standard deviation. So the standard deviation for this data set is about 2.6. So the standard deviation means that roughly it's pretty standard, it's pretty normal for our data to be off of the mean by about 2.6. Yeah, that's what it means. That's what it means. So standard deviation is a measure of spread. It's telling us how far away our numbers are, our data is from the center. So do you think the standard deviation for each student's spelling bee scores will be the same? And if you can go back and you can take a look at the box and whisker plots. If yes, tell me why. If not, if you're like, I don't think they're the same, tell me who do you think is going to have the lowest standard deviation? So go ahead, hit pause, jot down your thoughts, hit play to keep the discussion going. So first of all, I went back to the box and whisker plots. I'm going to come back here. And I can see that the spread is not the same, right? Some of these are more spread out than others. Like check out Tamar. Tamar's is way spread out. He's going to have a pretty high standard deviation. Jack and Aaliyah are a little closer together, and I'm having a hard time deciding between the two. Aaliyah has a really tight box in the middle, but Jack's minimum to maximum is smaller. So one of these two is going to have the smaller standard deviation. It's going to have less spread. So no, I don't think they're going to be the same. And I think it's going to be Aaliyah. She has that tight little box in the middle. I think Aaliyah's score is going to have the least standard deviation because her box plot is clustered right around the mean. It's pretty tight. I could be wrong, but that's what I think. I do think Timar is going to have the greatest standard deviation. His stuff is like way spread out. So I think Timar is going to have a really big standard deviation. I also think I just misspelled his name. I'm sorry. So each student's data shows a pretty symmetric distribution. So the mean is going to be the better measure of center. And since the mean is going to be the better measure of center, the standard deviation is the better measure to use to describe the spread. So we're going to start with Jack. I would like you to start, we have A, B, C here, walk through each one, but start by determining the mean of Jack's data. Hit pause, find the mean, hit play to check your work. So to find the mean, I'm going to add them all up. And we said these were their 10 most recent scores, right? So I'm going to add them all up and divide by 10. So I totally did that. When I added these up, I got 500 on the nose and divided that by 10. So it looks like Jack's mean is 50. Now, we said the next step, if we're finding that standard deviation, the next step is to go ahead and subtract it from all of these, all right? So you're going to take that mean of 50, and you're going to do 30 minus 50, 32 minus 50. You're going to subtract, 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 subtract. You're going to leave this box empty. Don't fill in this box. I don't want that box. Don't fill it in. And remember what we did next? After we subtracted, how we squared all of them and then added. So I want you to fill in this table. I want you to subtract, 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 square, 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 and then in the very bottom box, add up all your squares. Go ahead, hit pause to work this out, hit play when you're ready to check your work. So I started off by subtracting minus 50, minus 50, minus 50. I just did it all the way down, all the way down. So I was like negative 20, negative 18, negative 17, negative 15, negative 1, 0, 0, 21, 23, and 27. I did tell you guys not to add those up, so we marked out that box. Now, square them all. So square, 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 square. And this is why I have a calculator. If I square them all up, I got 400, 324, 289, 225, 100, 441, 529, and 729. So here they are all squared. Remember, you square a negative, it becomes a positive. And it did say to do the sum. I told you not to do the sum of these, but it turns out if you added those up, it would equal 0. You didn't have to do that. I did have you mark out that box, but if you did, you would have found that it was 0, and it should be. If 50 is my median, then all of these together, all of their deviations should bring us right back to the center. All right. Add all of these up, all of our squares. Did you add them all up? Because I did, and I got 2,938. I had a pretty big number. All right, let's finish this off. Now we have our table filled in. Let's determine the standard deviation. We said we're going to take this. We're going to do so this is where we take this guy. Do you remember what our next steps were? Divide by the number minus 1, and then do the square root. Hit pause. So divide by our 10 minus 1 and then do the square root. See what you get. Hit pause, work this out. Hit play to check your work. So I'm going to take this number. We had 10 scores, so I'm going to divide by 10 minus 1, which is, of course, 9. And this is why I have a calculator. When I divided, I got 326.4s forever. And when I did the square root, I got 18.07. So Jack has a median of 50 and a standard deviation of 18.07. All right. So it looks like this is his measure of spread. It's a pretty wide measure of spread. It's not terrible, but it is a little wide. I would like you to do all of this all over again. Do the median, fill in the table, find the standard deviation. I would like you to do this all over again for Aaliyah, and then I'd like you to do it all over again for Timar. Go ahead, hit pause, work these out, and then hit play when you're ready to check your work. So the first thing I did was I found the mean, right? So I'm working with Aaliyah. I added them all up and divided by 10. So 500 divided by 10, 50. No surprise. We noticed their means were all, their middles were all sitting about the same place. So now I'm going to take my 50. I'm going to subtract like crazy. And I got all of these lovely numbers. Now that I've subtracted, I'm going to square them all. Square, lots of squares. And at any point, of course, you can hit pause to double check your numbers. That's fine. We know if we add these up, we should get a 0. It's also a nice way to double check. If you add these up, you should get a 0. And then I also added up all of these guys. Thank goodness for calculators. And I got 1998. That was an okay year. We'll deal with her standard deviation in just a minute. We'll come back to Aaliyah's standard deviation. We filled in the table. It did say to complete the table. We filled in the table. We'll finish off Aaliyah's standard deviation in just a little bit. Let's fill in Tamar's table. So again, I added them all up. I divided by 10 because we had the last 10 scores. Again, I got 500 divided by 10, which is 50. We're not surprised. They were all kind of sitting around the same spot in the middle. I'm going to subtract 50 from all of these. Subtract. We know if we add those up, they should be 0. So it's nice to be able to double check that. Square, everybody. Square. And then I'm going to add all these up. And I got a really big number. I got 10,388. Oh my gosh. Okay. Finish it off. We've got Aaliyah's table filled in. We've got Tamar's table filled in. Finish it off. Remember to divide by the number minus 1 and then do the square root. So hit pause, work these out to find the standard deviation, hit play to check your work. All right, so I'm going to take my 1998. There's 10 of these, so I'm going to divide by 10 minus 1, which is, of course, 9. I'm going to use my calculator. 1998 divided by 9 is exactly 222. Terribly convenient. If I do the square root, I get about 14.90, something like that. Which is less, actually, than Jack's from earlier, right? So Aaliyah has a smaller standard deviation than Jack does. Let's check out what's going on with Tamar. That was such a big number. I'm going to take it and divide by 10 minus 1, so it would be 9. If we divide those, I got 1,154.2s going like forever. And then I did the square root, and I found out, oh my gosh, Tamar's standard deviation is 33.97. But we're not surprised by this because we noticed that Tamar's box and whisker plot was really spread out. So he's got a much bigger spread. So was our prediction correct? And what do these standard deviations tell you about each student's spelling bee scores? Well, it tells us Aaliyah has the least standard deviation, which means her spelling bee scores are the most clustered around the mean. It's pretty tight. And Tamar had the greatest standard deviation. His spelling bee scores are the most spread out from the mean. And we kind of predicted that. Like, we kind of saw that coming. So which student do you think Miss Webb should add to the spelling bee roster? Looking at the mean and the standard deviation for the student you recommend to add to the roster to justify your answer. Who should you send and why? Go ahead and hit pause, hit play to keep the discussion going. So I chose Aaliyah. I think Miss Webb should add Aaliyah to the spelling bee roster. They all had the same mean, but Aaliyah is the most consistent, right? Because her standard deviation of 14.9 is the lowest, that means her data is the mostly hanging around that mean. It means that she's very consistent in her scoring. So I would pick Aaliyah. If they all have the same mean, if they all have the same average, then I would go with Aaliyah just because she's more consistent, that tighter standard deviation. Jack's standard deviation and Tamar's, they were just bigger, and it just made them a little less consistent in their scoring. That's all. I hope you found this helpful. I hope you found this useful. If you got questions or concerns, let me know, and I'll see you guys soon. Bye.